Hey guys, this video is for graphing slope-intercept equations and inequalities. We're in Unit 3A. Our essential question is, why are multiple representations important? So clearly there are some times where using slope-intercept form would be more beneficial, but sometimes using other forms would be beneficial as well. So it just depends on the problem, and that's why multiple representations are important. So we have already talked about slope-intercept form, but this time when we're talking about it and we're going to graph it, it's not already going to be in slope-intercept form, and we have to get it to that form. So let's review what slope-intercept form is. Well, it's called slope-intercept form because it gives us a slope and an intercept. So our slope-intercept form is y equals mx plus b. The slope part of this equation is going to be the m value. So m always represents slope for us. And the intercept part is going to be the b value. So this is the y-intercept. So not just any intercept, it's the y-intercept. And just as a special note, this is also considered our starting value. So when we have a word problem, that's our starting value, or whatever we start with in that problem is going to be the y-intercept. Okay, and that's also our starting point when we are graphing as well. So we're going to review by graphing slope-intercept form equations that are already in slope-intercept form. If you're confused on this, you need to catch up by watching the other video over slope-intercept form. But I'm going to go ahead and briefly cover this real quick. So we have y equals mx plus b in number 1, except it's a little out of order because the b is first and the m is second, but it doesn't really matter, right? Mx plus b is the same thing as b plus mx. So the order doesn't really matter as long as the signs are there. So our slope here, remember, slope is always attached to your x value. So the slope here would be -2. But we also want to write it as a fraction because we want to know a rise and a run because we need it to graph. So this would be -2 over 1 or 2 over -1. And the reason why we write the equivalent form or the other form over here is because sometimes we can't use the first slope and we use the second one, but they mean the same thing. They're both still -2. And then our y-intercept is our b value, which is all by itself written as the point 0, 4. Now when I start graphing, I always want to start with the y-intercept, and that's on the y-axis at +4. And then my slope I'm going to use is going to be -2 over 1, so I'm going to go, starting at my y-intercept, I'm going to go down 2 because it's -2, and then I would run +1 because it's a +1, so I'd run to the right. And then I want at least 3 points on my graph, so you want to keep going. If you want to do more than 3, you are more than welcome to, but I only require you to do at least 3. And that is number 1. Number 2, we have x equals a number. And anytime it's just a variable and a number, you have to think to yourself, okay, this is either going to be a horizontal line or a vertical line. So if this was like y equals 3, then you would want to think the same thing. Now, because it says x equals a number, x equals indicates to me, well, I need to look at my x-axis. And on my x-axis, I'm going to put a point at -4. Okay? So you want to always follow your tick marks. So you see these blue lines and how they go up and down like this? You want to create a line that's also up and down and follow the tick marks as well. So this is a vertical line. And our slope here, this makes a U shape with our axis, right? So the slope is going to be undefined. Do we have any y-intercepts here? No, we don't. And the reason why we don't have any is because this is a vertical line and it's parallel to the y-axis and it's never going to intersect. So there are no y-intercepts. However, there is one type of intercept, and it's an x-intercept. So we do have an x-intercept, and it is the point -4, 0. Okay, so that's just a review over those two. Again, if you're confused on those, then you do need to catch up by watching the other video. Okay, so the next 5 problems, you want to identify the slope and the y-intercept using the equations. And just to remind you, the slope-intercept form is y equals mx plus b. And in slope-intercept form, the variable that's all by itself is the y, right? It's y, and it's all on one side, and it's all by itself, and that's how we want it. So if the equation doesn't already have y by itself, we need to get the y by itself. And we'll get there soon, but let's go ahead and start with number 1. This is already in the form y equals mx plus b. So we don't have to actually do any work with this one. The slope, or the m here, is going to be +3 over 1, okay, or -3 over -1, but you don't need to write both here. Our y-intercept is going to be 0, 5. Okay, so that one was pretty easy because it was already in the slope-intercept form. Number 2, y equals 1/2 x. The y is already by itself, so this is also in slope-intercept form. Okay, let's use green. The slope here would be positive 1 over 2 or negative 1 over negative 2. There is no number over here, so we're like, what's supposed to be over here, right? Well, if there's nothing over there, what's nothing as a number? It's 0, right? We just don't put plus 0. So what really is our y-intercept? It's the point 0, 0, the origin. Okay? Moving on to number 3. Here we have x plus y equals 7. Now the y is not by itself, so we do have to get the y by itself. So I'm going to go ahead and solve this like an equation. We want the y by itself, so we need to get rid of the x and move it to the other side. To move it, we would have to subtract it on both sides. Okay? So then I would have y equals 7 minus x. And now it's in y equals mx plus b form. Even though the b is in the front and the mx is in the back, that's okay. Now first we want to identify the slope, and the slope is the number attached to the x. What number is really attached to the x in front of it? A negative 1. So our slope here is negative 1 over 1. What's our y-intercept? Our y-intercept is going to be the 7, so 0, 7. Okay. Moving on to number 4, we have 4y equals 3x plus 12. Again, here we don't have y by itself, so I'm going to have to solve this one like an equation. So I'm going to go ahead and draw the line down the middle. Now 4 and y are connected by the operation of multiplication. 4 is being multiplied to y. So in order to get rid of the 4, we have to do the opposite by dividing by 4. And once you divide by 4, you have to divide everything by 4, because anything you do to one side, you have to do to the other side. So on the other side, I'm going to divide this by 4, and I'm going to divide the other term by 4 as well. 4 divided by 4 is 1, so they cancel, and I have y equals. Now before you write down the next part of this, I do want to remind you, or just let you know, that 3x divided by 4 is the same thing as writing 3/4 x. For graphing, it's more beneficial for you to write it this way because it shows us clearly where our slope is because it's right in front of the x. When the x is in the numerator, it can be hard for us to see the slope. So instead of writing 3x over 4, we're going to write 3/4 x. And then anytime you have a slope like that, you always want to make sure that the fraction is simplified. But 3 divided by 4 can't be simplified any further, so you just leave it as is. And then you have positive 12 divided by 4, which is going to give me positive 3. So from here, I'm able to identify my slope and my y-intercept because it's in y equals mx plus b form. The first part of this is the slope, 3/4, because it is attached to the x. So our slope is positive 3 over 4. And then our y-intercept is the point 0, 3. Okay. So again, more work than you need to do, but it helps us get in a slope-intercept form, which is what we're common in, or not common, but used to. Commonly known. Is more commonly known as, I guess. Okay. Let's do pink. Okay. I keep saying okay. 3x plus 2y equals 6. We are on number 5. And this definitely does not have y by itself, so we're going to go ahead and draw a line down the middle. Now, there are two ways that people think here. And the first way is you either subtract the 3 or you divide the 2. And so let's go ahead and have a practice problem over here. If I had 3 plus 2y equals 6, and I asked you to get the y by itself, the first thing that you would do is you would subtract the 3, right? So you would do the same thing here. Before dividing by the 2 in front of the y, you would subtract 3x on both sides. So then you have 2y equals 6 minus 3x. And the reason 6 and 3x are just next to each other is because they are not like terms, so you cannot combine them. And then at this step, your y is almost by itself, except you have a 2 attached to it, and it is connected by the operation of multiplication. So you want to divide everything by 2 so that you can get rid of it. Okay, so 2 divided by 2 is 1. Whoops. And then I have y equals 6 divided by 2, which is 3. And then negative 3 divided by positive 2 is negative 3 over 2. And we want to write that x on the side so that we can clearly see our slope. Okay, so let's identify our slope here. We have our slope of negative 3 over 2. And the y-intercept is positive 3, so 0, 3. Okay, so this is what we're going to be doing and using in order to graph our equations. So this video will be 2 parts. So we'll graph equations, and then we're going to graph inequalities. Okay, so let's graph the following equations. The first equation that we have is 3x plus y equals negative 2. So we need to get the y by itself because it's clearly not in slope-intercept form, right? It's not in y equals mx plus b form. So we're going to have to solve this like an equation. To get the 3x to move to the other side so we can have that y by itself is we need to subtract 3x on both sides. So we have y equals negative 2 minus 3x. And now I have y equals mx plus b. Okay, our slope here is going to be negative 3 over 1 or 3 over negative 1. And our y-intercept here is 0, negative 2. So when you start graphing, you always want to start with the y-intercept, just like we reviewed at the beginning. So we're going to start at 0, negative 2, so that's going to be on the y-axis at negative 2. I'm going to use the first slope, negative 3 over 1. So starting at my y-intercept, I'm going to go down 3 and to the right 1 because it's positive. I can't keep going, but I know that I want at least 3 points, so I'm going to go ahead and use the other slope as well. So we're going to go starting back at the y-intercept, the blue dot, and go up 3 and to the left 1 for negative 1. Okay, so I use both of those slopes, and I circled the colors how I got those points. So here is our line. So there it is. Okay. So it's not too bad. You just got to get the y by itself, right? All right, next equation, we have 5y equals 2x. Now we want to get the y by itself, and it's not currently by itself, so let's go ahead and draw a little line down the middle here. 5 and y are connected by the operation of multiplication. You want to get rid of that 5 by dividing both sides by 5. So 5 divided by 5 is 1, and you have y equals 2/5 x. Remember, you want to write that x on the side so that you can see the slope. Our slope here is going to be positive 2 over 5 or negative 2 over negative 5. Either way, they're both equivalent to positive 2 over 5. The y-intercept here, well, there's no number over there, so the y-intercept is going to be 0, 0, right? If there's no number, it doesn't mean that there isn't a y-intercept. It's because it's just 0 over there. So I'm going to plot the y-intercept at the origin because it's 0, 0. I'm going to use my first slope of positive 2 over to the right 5. So I'm going to go up 2, because remember, it's rise over run, up 2, and then positive 5, so I'm going to go to the right 5 units. And then on the next, I need another point, so let me go start back at the origin where my y-intercept is and go down 2 and to the right 5, because I'm using the other slope. And then I'll go ahead and draw a line through all of that. And we want to make sure there's arrows because that line does keep going. Okay, moving on to number 3. 2x plus 3y equals negative 9. So again, we need to draw a line down the middle, get that y by itself first. The first thing I'm going to do is I'm going to subtract 2x on both sides. 3y equals negative 9 minus 2x. And the next step here is to divide everything by 3. So because there's a 3 attached to the y, you want to divide everything by 3. Make sure you do everything or you will make a mistake. 3 divided by 3 is 1, so that would be just y. Negative 9 divided by 3 would be negative 3. And then negative 2 divided by positive 3 is just negative 2 over 3. And then the x is on the side over there. So our slope here is going to be negative 2 over 3 or 2 over negative 3. So you just choose where you want that negative sign. And then our y-intercept is going to be the point 0, negative 3. So make sure you get all those negative signs in there. So we're going to plot the point at 0, negative 3 on our y-axis, and then we're going to use our slopes. So the first slope I'm going to do is I'm going to go rise of down 2, so down 2 and then to the right 3 because it's positive. And then I'm going to use the slope, let's use purple, of 2, negative 3 with my other point. So up 2 and then to the left 3 because it's negative. Now it makes sense that my line is in the negative direction because my slope was negative, right? This slope is negative. So I should be a negative line. So that's one way you can check yourself to make sure you're doing this correct. And all your points should be in a line, and if they aren't, then you probably graphed it incorrectly. Number 4 is a common problem that we see, and it's also a problem that we get mixed up a lot on, and it's just some small mistakes here and there. So I would put a star next to this one just so that you pay attention and know, hey, like I should watch out for some stuff on here. Okay, So the first thing I notice is y that's not, the first thing I notice is that y is not by itself. So I'm going to draw a line down the middle and get that y by itself. The first thing I do is I subtract 4x on both sides. 4x minus 4x is 0. And what I have left on the left side is negative 3y equals 12 minus 4x. Okay? Now those are not like terms, so you want to write them next to each other. The next step here is you want to get rid of the negative 3 in front of the y. So you would divide by negative 3, and you would divide everything by negative 3. Okay? Negative 3 divided by negative 3 is just 1, so just you have 1y, or positive 1y over there. 12 divided by negative 3 is negative 4, and then here's where we run into the mistake. Negative 4 divided by negative 3 should be positive, right? A negative divided by negative will give me a positive. The most common mistake that I see is that they keep the negative sign there. You want to make sure that you check a negative divided by negative is a positive. And I know for a fact, right, that these two negatives will cancel each other out and make it a positive. And so you're going to have positive 4 over 3x. So the most common mistake I get is that they just put only a negative sign because they see negatives here and they put a negative down there. However, it is positive because a negative divided by negative is positive. So again, I just wanted to draw your attention to that common mistake that I see a lot. Our slope here is going to be positive 4 over 3 or negative 4 over negative 3. And then our y-intercept here is going to be 0, negative 4. So go ahead and plot that point and use my slope of positive 4 over 3. So I'm going to go up 4 to the right 3. Up 4 to the right 3. And this is a positive line, which makes sense because our slope was positive. Okay. Moving on to the second part of the video, we're going to talk about graphing inequalities. Before we graph inequality lines, we need to first talk about inequalities. So there's 4 types of inequalities that we know of. We have this inequality, we have this inequality, that, and this. You're like, that, this. Well, we need to identify what these are, right? So the first inequality sign, and if you can't tell which one's less than or greater than, I have a trick, right? So I showed this video when we were first talking about inequalities, but if you can't figure out what the less than sign is, remember this looks like an L for less than. So the less than signs look like an L. So our very first sign here is going to be a less than, and then the second inequality sign would be greater than. Okay, so remember the less than sign looks like an L. The next sign is less than, but it has a little line under it, which also means equal to, because it's part of an equal sign. So this would be less than or equal to. I call it the equal to line, or equal to bar sometimes. And then we have greater than or equal to. Okay, so we have less than or equal to, and greater than or equal to. Now, here are some things that you need to remember when you're graphing inequalities. When we were graphing lines, all we had to do was just plot some points and then draw a line through it. However, we can't be too impulsive and do that with every single inequality. There are certain things that you have to remember to do before you graph inequality lines. The first thing is that if you have a less than or a greater than sign, the line is going to look a little bit different. And I'll show you what I mean. So back when you were learning just graphing inequalities, so you don't have to write this on your paper, but I'm going to go ahead and write this. You would be given a number line, right? You would be given a number line, and you were asked to graph x is less than 3. Okay? Well, you'd be like, okay, well, I'll mark a point at 3. And then before you put a point down, you have to think, is it an open circle or a closed circle? This would be an open circle because there's no equal to line here. So you would have an open circle, okay? Now, if you would have a closed circle, that means you'd have an equal to sign here, and then you'd fill it in, right? So you either have an open circle or a closed circle. But once you finish that, you couldn't just stop. You needed to shade. You either shaded to the left or you shaded to the right, depending on your inequality sign. Well, this says x is less than 3. Where are all the numbers that are less than 3 on the number line? They're all on the left side. So I would graph and shade this way, okay? So you're going to do the same thing with lines. It's just a little bit different. Instead of open and closed circles, we have dashed and solid lines. So if you have a less than or a greater than sign without any equal to's, when you graph, your line is going to be a dashed line that looks like this instead of a straight solid line. But if you have a less than or equal to or a greater than or equal to line, do you see how there's solid lines underneath the inequalities here? There are solid lines here. So when you graph, you're going to have a solid line. So that's a trick that I use to help people remember. So if you have a solid line under your inequality, you have a solid line when you graph. Okay? So so instead of open and closed circle, you have dashed and solid lines. So it's just a little bit different. Okay? Again, the trick is if you have a solid line here, you're going to have a solid line when you graph. The second thing after you decided if it was an open or closed circle was whether you shaded to the left or to the right. Well, graphing lines, you're also going to shade. It's very rare that we call it left or right. We normally call it above and below. So let's talk about shading above and below. If you have a less than sign or a less than or equal to sign, so if you have a less than, you're going to shade a certain direction. You're either going to shade above or below. Now, when you think of less than, or you think of someone less than you would shade below, because if someone's less than you, they're below you, right? So if someone's less, you shade below. So that means if you have a greater than or equal to, you would shade above. And I know none of this really makes any sense right now, but when we get to actually graph, we'll talk about it and you'll get to see it in play, in action. Now, we haven't used it, so again, it might be a little confusing, but you just have to remember. So instead of open and closed circle, you have dashed and solid lines. And instead of shading left or right, you would shade above or below. So, number 1, I have y is less than 1/2 x minus 3. So the first thing I would check for is this in y mx plus b form? And I would say yes. So what is my slope here? Okay, I'm going to treat it exactly the same. The only difference is that you have an inequality instead of an equal sign. So your slope here is positive 1 over 2 or negative 1 over negative 2. And then our y-intercept here is going to be 0, negative 3. So you would do the same thing as you would normally do, and you would graph your y-intercept first, so 0, negative 3. And then I'm going to go ahead and use my first slope here. So I'm going to go up 1 and to the right 2. Up 1 to the right 2 because of those positive. Now, once you've graphed at least 3 points, then you have to think, okay, before you draw a line through this, because instinctively and impulsively you want to draw a line through it, but you have to ask yourself, is this going to be a solid line or a dashed line? Now look at your inequality that you have. You have a less than sign, no equal to. There's no solid line under that, so you're going to draw a dashed line. So you're just going to have a little dotted line or dashed line, whatever you want to call it, and just make sure you go all the way through your whole graph. You still have arrows, it's just a dashed line this time. Okay? Okay, now once you have your dashed line, you're going to have to shade as well. So here, because I have a less than sign, so this is less than, okay, because it's less than, I'm going to shade below. Oh my gosh, so sorry. My Apple Pen's being weird. Shade below. Okay. And you're like, well, where's below on my graph? Well, there's 2 parts of your graph here. You have this first part over here, and you have this bottom part over here. Now, which one of those is below? And if you can't tell where below is, it's helpful to know, well, if you imagine. So let's imagine. Let's look at our y-intercept, right? Look at your y-intercept, and I want you to imagine it moving up. So if you were to move your y-intercept up anywhere, would that be above or below? That would be above. If you imagine your y-intercept moving down, that would be below. So if you're confused on where above and below is, just think about your y-intercept. If you're trying to go below, move your y-intercept down. And when I move it down, it's in this part of my graph. So when you shade, you want to shade that entire side of the graph. So over here, I'm going to shade all of this. I'm going to shade all of this side of my graph here. Okay. And then the next thing I want to mention is something that I left off of the notes. So there's things called solutions and non-solutions. So go ahead and write solution on the side of your paper and then non-solution as well. Okay. Let's talk about what a solution and a non-solution is. Okay, solutions are in the shaded area. So any point in that shaded area could be a solution. So for example, the point 4, -3, so 4, -3 down here, so +4, -3, that is a solution because it lands in the shaded area, so 4, -3. But it's not the only solution that we have. There's lots of other solutions. Any point in that region is considered a solution. Oh my goodness. I'm trying to erase the dot without erasing the line, but it's so hard. Oh my gosh, I had it. There we go. Okay. And let's see, what's another solution that we could have? Another solution could be 2, -5, right? This is also a solution. So any point in the shaded region is going to be a solution, okay? A non-solution is in the non-shaded region. So for example, the point 0, 0. 0, 0 would be a non-solution. Or 2, +2. That's also a non-solution because it lands in the non-shaded area. So a solution is in the shaded and the non-solutions are in the non-shaded, okay? And we'll get more practice with that in a little bit. Okay, so let's move on to number 2. This is already in slope-intercept form, so it's y and then mx plus b, except our mx and our b are swishing around a little bit, but that's okay. So our slope here is going to be -2/1 or 2/-1. And then our y-intercept is going to be 0, 5. So I have a positive y-intercept at 5. And then I'm going to use my slope to graph, so -2/1. So I'm going to go down 2 to the right 1, down 2 to the right 1. Because my slope was negative, it makes sense that my line is a negative line. Now before you keep going, you want to look at your inequality sign. Your inequality sign is greater than or equal to. Do you see how there's a solid line underneath? It says equal to. Then when you graph, you're also going to have a solid line. So just make sure your line goes all the way through your graph so that it cuts your graph into 2 parts, okay? So you have a part over here and then you have a part over here. Okay. Once you're done drawing that line, you want to shade. And just to remind you again, we have a solid line because we have a solid line here. Over here, we didn't have an equal to line, so that's why it was a dashed line over there. Okay, now we need to shade. Because this is a greater than inequality, you want to shade above. Above your line would be over here. Okay, so this is all above. That's above the line. You can shade in, so I have some students that do this as well, where they shade in like this, and that's okay. It's just a little bit messy, so I just prefer to draw little lines because when we get to Unit 5, it helps to just draw lines like this. Okay, and if you didn't know where above is, remember, imagine your y-intercept. If you're trying to shade above, you want to move the y-intercept up, and when I move it up, it would be on this side of the graph. Okay, so for example, let's figure out, is the point 0, 0 a solution to this? No, it is not, because it lands on the outside of the shaded part. So 0, 0 would not be a solution. Would the point 4, 2 be a solution? Yes, because 4, 2 lands in the shaded part. 4 is also a solution. -3, 0 is a non-solution. So again, non-solutions are in the non-shaded, solutions are in the shaded. Okay. And then we're almost done with the notes. We just have, I think, 5 more examples left or 4 more examples left. 4 more examples left, so we're almost done. On this page, you're having to graph inequalities again, but these inequalities aren't in slope-intercept form already, and we have to get it in slope-intercept form. So I have a reminder here that when you divide or multiply by a negative, okay, you want to flip the inequality sign. So you have to flip the sign. So if you had a less than sign, it would flip to a greater than sign. And if you have a less than or equal to sign, it would flip to a greater than or equal to sign. So you want to flip it if you divide by a negative number. Okay? So starting on number 3, we have x plus y is less than or equal to 3. Well, because y is not by itself, I cannot graph it the way it is. So you still want to treat it like an equation by getting that y by itself. So in order to get that by itself, I would subtract x on both sides. X minus x cancels and becomes 0. I have y is less than or equal to 3 minus x. So my equation, or my new equation, is now this. Or not equation, inequality. My slope here is going to be -1/1, because it's what's attached to the x. my y-intercept here is going to be 0, 3. Okay, so you want to graph this on your graph. So 0, 3 would be up here, and then you want to use the slope of negative 1 over 1 or 1 over negative 1. I'm going to use the first slope, so down 1 over 1, down 1 over 1. So this is my line. Before you draw a line through it, you need to check, do I have a solid line or a dashed line here? This would be a solid line because you have a less than or equal to. The equal to part of it makes it a solid line. So I'm going to have a solid line. You want to make sure it goes through the entire thing. Okay. And then you also have to shade. Well, because I have a less than symbol here, I want to shade below. So less than means below, greater than means shade above. So I would shade below here. So I'm going to go ahead and draw and shade in. And again, you can do you can shade in the entire thing with your pencil. However, I prefer to just shade in. So that's a giant area for solutions. Now, I don't know if anyone had asked this or is thinking this in their head, but I want to go back to the last two graphs. So when I asked for solutions and non-solutions, solutions were in the shaded area and the non-solutions were in the non-shaded area. And so when you think about it, remember the dashed line is because the inequality sign is not equal to. So any point on the dashed line is not a solution because it's not equal to. But because this one's a solid line, because it's a equal to inequality, then any point on the line is a solution. So it depends on where the point is on your line and whether it's an equal to or not equal to. So for example, the point 0,3 is a solution because the line goes through that point and it's a solid line. 0, 0 is also a solution, but the point, let's see what's a non-solution. The point 50 would be a non-solution because it's in the non-shaded, okay? So solutions are in the shaded, non-solutions are in the non-shaded. Because the line is a solid line that is equal to, any point on it is also a solution. Okay, moving on to number 4, we have 3x minus 4y is less than 8. You want to get the y by itself, and again, I'm going to put a star next to this one because anytime the y is negative, we tend to make mistakes. So we're going to go ahead and get the y by itself. The first thing I would do is I would subtract 3x on both sides. 3x minus 3x is 0. So I have negative 4y is less than 8 minus 3x because they're not like terms. And then the next thing I would do is I want to divide everything by negative 4. All right, there's two mistakes that we make here. The first mistake is, well, I've divided by a negative. What happens when I divide or multiply by a negative? My inequality sign flips the other way, right? So now it is a less than sign. Okay, it's no longer greater than. What happens if you forget to flip it? You're shading the wrong way. If you have a less than or a greater than and you forget to flip it, you're going to shade the opposite direction, so everything after it is going to be incorrect. Negative 4 divided by negative 4 is just y. Okay? 8 divided by negative 4 is going to be negative 2. I don't know why that's in a different color. Let me go ahead and change that back. Is negative 2. And then here's the second mistake that we make. Negative 3 divided by negative 4 is a positive 3 over 4. Okay, negative divided by negative is a positive. And we forget that sometimes. We do. It's just what happens. So the mistakes that we commonly make are in baby blue. And I'll go ahead and make the star baby blue so that we know. So those are the ones that we commonly make a mistake with. We forgot to change the inequality sign, and we forget that a negative divided by negative is a positive. So our slope here is positive 3 over 4. Or negative 3 over negative 4. And then our y-intercept is 0, negative 2. So I'm going to plot the point 0, negative 2 on my graph. Actually, let me change this because I don't know why it's that color. Oh no. Nope. Let's see. Pink. Use the first slope, up 3 over 4. Can't keep going, so let's go ahead and use the other slope. What color have I not used? This one. So we go down 3, negative 4. So to the left. That's a big dot. Let me go ahead and fix that. Okay, so they should all be in a straight line. Now before you draw a line through this, you want to ask yourself, is this a dashed or a solid line? This is a dashed line because, remember, this is our equation, our inequality now. Whoops. This is our new inequality, and our inequality sign is a greater than sign, not equal to. So if it is not equal to, you want to make sure you have a dashed line going through all these points and all these lines, or all these points, I guess. And then make sure you're looking at the highlighted inequality. It's a greater than sign, so you're going to shade above. Greater than means you shade above, less than means you shade below. So I would shade above here. So a big area for solutions. So is the point 0, 0 a solution? Yes, it lands inside my shaded area. Is the point 1, 0 a solution? Yes, it lands on my shaded area. Is the point 3, negative 2? No, it's in the non-shaded, so that's a non-solution. The point 0, negative 2, our y-intercept, is a non-solution as well because this is a dashed line, so it's not equal to here. So since it's a dashed line, any point on that line is a non-solution. All right, number 5, we have y is greater than or equal to negative 2. So this is just a y and just a number. So that means that I'm going to have just either a horizontal line or a vertical line. Because this is just a y, we want to look at the y-axis. Okay? And then you want to plot a point at negative 2. So on the y-axis, you're going to plot a point at negative 2, and you want to follow that tick mark. Because this is an equal to symbol, right? Because it's equal to, my line is going to be a solid line. Oops. And just for fun, what is my slope here? My slope is 0, right? It makes a z. And if you don't know what I mean like this. It makes a z. So our line is a horizontal line. And then we also have to shade. Now, because this is a greater than symbol, because it's greater than, I'm going to shade above. So I'm going to shade in this region up here. So some examples of solutions would be the point 0, 0. A non-solution would be the point 0, negative 5, right? So anything in the non-shaded is a non-solution. The y-intercept 0, 2, or 0, negative 2 is a solution because the line is solid there. So solutions, you could have 0, 0, or a non-solution could be negative, no, 0, negative 5. So something that's like down here. Okay. And then our last example, we have x is less than 2. So this indicates to me that I should look at my x-axis. I'm going to put a point at positive 2. So on the x-axis, I have a point at positive 2. You want to follow those tick marks. Because this is a less than symbol, I'm going to make this a dotted line because there's no equal to here. So we have a dotted line that goes through this. And then you have to shade. And you're like, whoa, there's no above or below, just left and right. Well, it says x is less than 2. Where are all the numbers less than 2 on the number line, right? If we're looking at a number line, where are all the numbers less than 2? To the left or to the right? To the left. So anything less than 2 is going to be on the left side of your graph. So anything on this side over here is going to be a solution. And any point on the dotted line is a non-solution. So that is it for graphing equations and inequalities. If you have any questions, please feel free to come into tutorials and ask.